Hey guys, doing a Autometer GPS speedometer sensor interface instruction today for a Holley. Decided not to use the Holley USB because we weren't going to use the dash, and there were no other options available in a short period of time that I could get. The customer was waiting on the car, and one of the last things I needed to do was get ground speed. And I liked that they had a separate antenna for the pickup. Um, and it's 16,000 pulses per mile, which is a little high. Didn't really need that many, but I figured the low frequency and the square wave would help me keep it clean. So I'm going to go on to the next step, which is we're in the Holley. I'm going to go on to the point where I chose the I/O. I chose GPS speed, just named it. Digital speed frequency. It is a digital square wave. I've got it on J2A30. It is also configured as a frequency input. Obviously, got it enabled, but under configure is where I was at here earlier. I chose 100 um, pulses per rotation, and the reason for that is I'll get into later. When I went to test out um, the calibration mode, which is important. When I had this number too high, it swept really slowly and wouldn't even make it to the 80-mile-an-hour calibration. Like I tried like 700 pulses per rotation, which is somewhere around like what a transmission does, but this does not work the same. So I kind of got that out of my mind, and I kept going down in this number to kind of find a good, reasonable speed match. And when I could actually get to 0, maybe 140 mile an hour, and it moves and sweeps very smoothly before it starts to wig out. I don't think any of these really go above 160 mile an hour, so keep that in mind. The only point I really got this for was to later use for um, tire spin doesn't exist in GPS. I wanted to compare a non-tire spinning input to a tire spinning input. And because this was a C601, I was having a heck of a time trying to get a good stable signal from the active front ABS sensors. So I'll go back and show you how I tested this. And what we'll do is obviously we'll start a video of logging, and then I'm going to take a video with my phone of us doing the calibration. Over how to quickly create a gauge to record that speed. As you can see here, I've actually modified the speed gauge that was here. You can double click that, set what channel, which is the one we just created, GPS speed. You can change this to whatever you want. I can say mile per hour, minimum 0, maximum 200, and click OK. You should be able to go to the next step and log while the engine doesn't have to be on. Just key on, have the Holley on, and then start your record over here. So I'm going to go ahead and start that now. All right, just for video purposes, this is the button I'm going to be pushing to watch on the GPS. And the point is to watch this GPS number climb. It'll start doing it slowly. And we want to get as close as we can to 80 without going over. And it's going to start climbing faster. All right, we hit 80. And now it's going to go back to 0. So now you're calibrated. Pretty much concludes the video. What I wanted to go over was what I'd learned from the directions. They were kind of vague. It's one page. But basically what we did was simulate the output. They're expecting you to have an actual gauge. We made our own gauge, obviously, by creating the Holley input and then the visual gauge. And what we did was we went through the continue to hold the speedometer button until it reaches 80, which is here. So what I'd found is when I came up with 100, I think I'd originally tried, like I said, with 700, and it slowly would never reach the 80 mile an hour. Too many pulses per rotation, you'll never get the speed you're looking for. And then what I also tried a low number, just for test purposes. I put like 5 in there, and it swept really fast, and I almost could even catch the 80 mile an hour. But what I found was in the low end, when you actually take off and drive, you might drive 25 feet down the road, or not 25 feet, but maybe 25 meters per se, and get nowhere on the gauge until all of a sudden it'll pop up at 35 mile an hour, and then it's good. So I don't think it has enough pulses per mile to complete the pulses per rotation simulation. So I would just try what works for you. I'm guessing it's going to be between the 100 and 200 range, and that's kind of what I figured out. And that's something you can play with on your own.